Today our focus is on solving quadratic equations. Now we've spent the last couple days graphing them, finding lines of symmetry and vertex points, but today is really going to be about going back to the tried and true solving of equations. Now really, to be able to do this, I have to make a zero happen at the end of whatever quadratic I have. So if I don't have a quadratic kind of equation on this side and it doesn't equal zero, I'm going to have to make it actually equal zero. So if I have to move stuff around, then I'm going to do that. Now when I actually find out what values of x would make an equation true for a quadratic, those are called roots or zeros. You'll probably hear them called zeros a lot more, but roots or zeros are the names of the x's that I can actually plug into here to give me zero on both sides. Now you can solve for this kind of in two ways. You can graph it, or you can solve symbolically. The big thing about solving symbolically is that it doesn't require me to take all the time to go through all the possible steps of finding the line of symmetry and the vertex point and another point and reflecting it. Solving symbolically lets me just go to what I already know how to do and solve. Now I wanted to give you kind of a couple examples here of what to look for as far as graphing. So if I were looking at these, let me move this just a little bit over. I don't know how we got so like not straight there, but okay. So if I were going to look at these graphings, this -4 actually happens to be my y-intercept. So down here at -4, this would be a graph that would open up and kind of look like this. Now when you're finding those zeros, that's really what's going to, when my x values are plugged in, when my y is actually going to equal 0, where are the points actually hitting at. So I can see in this one, it hits here and here. Now if I were doing an exact graph, I could look and say, oh, I know what this number is and I know what this is. But on something like this, I can at least tell that it hits the x-axis twice, which means that this kind will have two solutions. If I have x equals 0, that would be one that starts here, and then my graph would open up that way. So if I were to go through this and it were to hit that line, it would hit the x-axis once. This would actually be the minimum in this case, which means that this has one solution. Now in this last one, if it's +4, that means my +4 is going to be up here, and then my graph is going to open up like this. Now if I were to look at my x-axis here, it never hits it, which means that this would be one that would have either 0 solution or no solution. Either one would be okay. So knowing the kind of graph you have, the possibilities are you could have one solution, you could have two, or you could have none. So there's kind of different possibilities that could happen. So let's take a look at some equations to see how we can solve these. So if I'm going to solve symbolically on these, I want to be able to get x by itself. So I could start out, I could add 98 to both sides. So I get 2x squared equals 98. Then if I divide by 2, I get x squared equals 49. And if I want to figure out what x would be, really this is what number times itself, that's what the squared means, equals 49. So really I can do the square root of 49. Now do remember it could be the positive version or the negative version of that number. So if I did the square root of 49, it would be 7. So some people will write it as plus or minus 7, or some people will write it as x equals 7 or x equals -7. Either one is okay. But the main deal with this one, let me fix it, -7 here. The main deal with this one is I have to make sure that I know that if I were to put 7 back in this spot, 7 if I were to square it gives me 49, and negative 7 if I were to square it also gives me 49. So either one of these answers are acceptable. You will see more and more of this kind of an answer because that starts to be a big focus in algebra. So let's take a look at another one. On something like this, I already have the 13 over here, but I'm going to start by subtracting 6 from both sides. So I have 7x squared equals 7. Divide both sides by 7. So I have x squared equals 1. So to find x, I'm going to do plus or minus the square root of 1. So it's going to be plus or minus 1. Okay, let's see if we can try one more here. Now this one says solve by graphing. Really, if you want to solve symbolically, that's perfectly fine with me. Okay, in this first one, divide both sides by 2. So I get x squared equals 0. So x equals 0. Notice there's no plus or minus. This is really a good idea of where one solution you can really tell how that happens. Now in this one, if I divided it by 2, or excuse me, subtracted 2, then I'd have 2x squared equals negative 2. Divide by 2. So I have x squared equals 1, negative 1. Now my problem is, if you were to put this in your calculator, you're going to get an error because it can't just be negative 1. So because this does not work, that's going to be one that's going to be no solution. Now in this one, I'm going to add 2. So 2x squared equals 2. Divide both sides by 2. So x squared equals 1. So x equals plus or minus the square root of 1. So x equals plus or minus 1. Now this is a perfect example of where two solutions happens, because it's both positive 1 and negative 1. So I'm just kind of pointing that out so you have some kind of idea of what's going on.